So you're back for part 2. Let's start with the modeling functions: growth, LINEST, LOGEST, and trend. These are your fun array functions. They are your predictive modeling functions. So first, LINEST and trend, which are predictive models for linear trends, or y equals mx plus b. So all you need is an array of y values. These could be sales numbers, user growth, COVID cases, etc. I've just chosen a few random numbers for my y values and then plotted them on a scatter plot in this graph. Now the LINEST model is going to give you what your m and b values should be. Here, I didn't even have to specify x values because when you don't, Google Sheets is going to assume a regular sequence. And just to prove that to you, I'm going to use this regular sequence as my x values. And see, output didn't change. So now that I have my m and b values, I can plot this straight line. And this is the linear trend that's going to predict what other y values are going to be. So LINEST has 2 additional optional parameters. The first one is calculate b. This is true by default. If you set it to false, it will force b to equal 0, or in other words, force your linear model to go through the origin. The second optional parameter is verbose, and that is false by default. Now let's see what happens if you set it to true. So we'll say calculate b, true, verbose, also true. And it's going to give you these additional regression statistics. Now this last number is super important. It tells you how accurate your linear model is, and it's calculated by summing the squares of the differences between your predicted y values and your actual y values. There's actually an array function, sum x my2, that will calculate the residual sum of squares directly. So say you want to use your linear model and put it into action and predict what the sales will be for months 11, 12, and 13. So you can use the trend function to apply that LINEST model to these new x values that you have. So again, you're going to say, here are my y values, here are my x values, here are my new x values that I want to predict what the y values will be. And trend will extrapolate out your line for what your predicted y values will be in months 11, 12, and 13. Now LOGEST and growth act the exact same, except instead of being for linear models, they are for exponential models. I don't want to go super into detail and waste time because they work exactly the same, but just know that LINEST is to trend as LOGEST is to growth. So yay, we have covered all of the useful array functions. The rest of these array functions fall into that category of theoretical matrix calculus that you would really only use in Google Sheets if you're cheating on your high school math homework. So I want to be clear, there are definitely practical applications for calculating matrix determinants for eigenvectors in statistics, engineering, and physics. Most importantly, matrix operations are super important for computer graphics. But if you are a professional who needs to be working with matrices, you're not using Google Sheets. So let's just race through the rest of these to cover them, but not spend too much time on each. MDETERM calculates the matrix determinant of a square matrix. MINVERSE calculates the multiplicative inverse of a square matrix. MMULT calculates the matrix product of 2 matrices. Sum x2 my2 calculates the sum of the differences of the squares of 2 arrays. Sum x2 py2 calculates the sum of the squares of 2 arrays. And that's it. There you go. All of the Google Sheets array functions.